Good morning, or afternoon, or whatever it is where you are. Back in 2016, I had some questions about manure. Not about the actual spreading of manure or calculating the application rates, but about manure's role in sustaining agriculture. Is manure a sustainable organic amendment able to build soil organic matter levels? Is manure a sustainable source of nutrients? And how far can manure go in agriculture in both sustaining soils and their nutrient levels? So I wrote a series of essays on these questions, and you can get those online if you want to see the details. And that's what I'm going to cover today. So manure is promoted as a sustainable solution, but really, is it? So what I'm asking in terms of soil health is, can manure, the manure that we have, maintain the current levels of soil organic matter? So sustain that soil organic matter level in our soils. In terms of soil fertility, would that manure be able to replace the nutrients removed in the annual harvest of crops? That's what I'm going to be talking about. Our livestock produce a lot of manure. Every year, livestock in the United States produce about 335 million tons of manure. At 1 ton a minute, it would take you about 637 years to pile up that much manure. I want you to think about this. If we took that much manure and spread it equally over all the US cropland, how much manure would be available per acre each year? And I'll give you the answer to that in the end. But back to my question, would it be able to sustain our soils? First, let's look at what it might take to sustain soil health. So soil organic matter reflects the balance of what is added and what is lost. And in this ideal situation, you've got a crop that is harvested. So the biomass is taken off the field, it's fed to livestock, the manure is produced and then collected and then spread back on that field that produced the feed. It's an ideal situation, doesn't happen very often, but that's what I'm going to use to make these calculations. So we know there's losses in this process, and we also know there's losses of soil organic matter in the field. So how do they compare? On one side, we have the process that we just looked at, the crop to livestock to manure to spreading the manure back on the soil. On the other side, we have this continual loss of soil organic matter due to decomposition. We can sustain our soils when that gain is equal to the loss on an annual basis. Let's look at the losses on the feeding side first. So manure doesn't come from livestock, but originates with the crops. So I'm going to look at the total biomass produced by a crop that's harvested and taken off the field, and I'm starting with that. So on that basis, we can actually estimate a manure production per acre. And the loss in this process from crop to livestock is about 57, there's a range, 57 to 81%. This includes feeding losses, includes the production of meat, milk, and eggs, which is what we want, why we feed livestock, and so that's a good loss. Also includes respiration of the animals. The next loss is after it's produced. So you've got collection and transport. This is much less. It's only about 4 to 8% of that total starting amount that we harvested off the field, or about 10 to 40% of the manure excreted. So if you add this up from crop to livestock to manure to spreading it back on the field, you've got a total of 61 to 89% total dry matter loss between the crop and manure application. The range of losses and the production, it all depends on your type of livestock, what do you have, cattle, pigs, or chickens, the type of production system, and the region in the country. So I had to make some decisions, and I'm going to talk a little bit about those right here. So cattle by far produce the most manure, so these calculations are for them. I had two scenarios. One, I used average grain yield. The other one, I used irrigated silage yield with dairy. And the range here, this 1.6 to 5.7 tons per acre, and this is dry, of manure represents the range of production from the various systems of livestock. So this is what I'm going to use for our manure production rate. We've got one more loss to look at. And this is the loss that after you spread it on the soil or incorporate it in the soil, you still have some more decomposition before a portion of the manure becomes actual soil organic matter. So here, another 10 to 31% of that original dry matter is lost. Of the manure applied, only about 8 to 21% becomes soil organic matter. And in my calculations, I optimistically use the 21% because it matches results from a research project in Pendleton, which is fairly nearby. So if you add it all up, you end up with 92 to 99% of the mass is lost from crop to soil organic matter. It's not looking so good, but this needs to balance the losses in organic matter, which we haven't talked about. So let's look at them first. So we looked at the gain. We need to look at the other side. The amount you need depends on the amount of soil organic matter you have. So here, the losses, estimated losses in soils are about 1 to 5% of soil organic matter each year. So the more soil organic matter you have, the more inputs are needed to maintain it. The rate of loss, that 1 to 5%, varies depending on several factors that I'm going to talk about a little bit later. So we've looked at this, the gain, which is going to be about 21% of that manure rate that we have. And then the losses is 1 to 5% of your total soil organic matter in your soil. If you combine those two, you come up with a table like this. And here, if you look at the numbers, this is the acres of crop production required to produce the manure needed to maintain 1 acre of soil organic matter. So if the number is 1 down here, if we got a number that's less than 1, that means we can actually sustain organic matter levels with the production from 1 acre. Where we go into this yellow area where it's above 1, that means we need more than 1 acre of feed to produce the amount of manure needed to sustain organic matter of 1 acre. And you can see it ranges from 1.2 to 5.9. So in the yellow area, it takes more than 1 acre of manure. And this is in the range, in the ballpark of the others who have done the similar calculations. So I figure I'm pretty confident in these numbers. We can answer our question, can manure sustain the soil that produced it? The answer in general is no, except for soils with low organic matter levels or low loss rates. There is not enough manure produced to sustain the organic matter in lots of our soils. And because compost comes from crop or plant production, it's in the same boat. I'm not going to go through compost calculations, but it's basically the same type of deal. They cannot sustain or soil organic matter on the land that produced them, so it's not sustainable for agriculture in general. Can these amendments be used beneficially on some fields? Of course. They are good practices. I'm just saying they're not going to sustain organic matter in all our soils. This will always work. Take organic waste off a large land area, or not even organic waste, but the crop production in the case of manure. Apply it to a small area. It's always going to improve your soil, your plant growth, etc. There was an example in the headlines a few years ago where they took orange peels, applied it to a tropical forest, and you can see the difference on the right compared to the left of that the orange peels made after a while. I looked at the original research. The ratio of the area that produced the orange peels versus what they put it on was 30 to 1. Again, getting back to that idea that we're concentrating the organic matter or waste in this case from a large area to a small area. It's always going to work, but it doesn't scale. So what we have in these situations is an apparent abundance. It's like fish from the open ocean or hardwoods from the rainforest. Manure's abundance or scarcity is hidden because the distant sources make it difficult to see the production details. But what we really have with manure is a scarce resource. So I made some rough calculations again. How much of our cropland soil could be sustained by manure? And this is overall. about 20%. So when we look at farms, we can't generalize from those farms that are lucky enough to have large amounts of compost or manure available, and they can actually increase their soil organic matter levels. But they are localized exceptions. By itself, there's not enough manure or compost to sustain soil organic matter levels. There's some things we can do to change the rates here. On both sides of the equation, you can reduce your soil organic matter loss rate through some of these practices. You can also increase the additions to soil organic matter through some of these practices. And those did not come into factor in these calculations. So this is just based on the amount of manure going on a field or the amount of compost going on a field, and none of these other practices. So on to nutrients. I'm not going to go through all the calculations for nitrogen and phosphorus, but again, using that high and low manure production scenarios, the manure needed to replace nitrogen, here we have 22.2 tons per acre is needed. For phosphorus, it's only 3.8. So for the low scenario, you compare the needed to the produced, and you actually you need 13.9 times more area of crop production to produce the manure to replace that nitrogen on 1 acre. Phosphorus, it's only 2.4 in the high scenario, 3.9, and only in the case of the high scenario, high manure production for phosphorus can it be a 1-to-1 ratio or less. So that means that farms that are close to manure sources that can apply enough manure to supply the nutrients to their crops can only do this because there are other fields that are producing manure through feed crops that don't get enough manure in return. So again, it's not a sustainable solution in general. If we spread the manure over all the cropland, you can look at it by state, how much manure versus how much, if we spread it all over evenly, how much nitrogen and phosphorus you would get. You can see they're fairly minimal numbers. 9.4 pounds per acre of nitrogen in Washington, only 2.4 pounds of phosphorus. Washington has lots of cropland, not such high manure production rate. It's always good to get a second opinion. These maps are from USDA, and they look at, again, spreading the manure that's in each county. They go by county, spreading the manure that's produced in that county on the cropland in that county. How much of the nitrogen that is needed could be supplied from the manure. You can see here, very few counties can provide 100%. A little bit more can provide 50 to 100%, but almost all the counties are less than 50%, and most of those counties are significantly less than 50%. If you look at phosphorus, it's a little better case in some counties, but not much better. Again, we're not producing enough manure to provide, to replace the nutrients that we need from crop harvest. So in general, manure is not a sustainable source of nutrients. For individuals, farmers, yes, but not for agriculture. Why? Because it will not sustain anywhere near our current production. And that's because of the losses that we talked about. So soil health in general requires manure plus those other management options that I mentioned before: high residue crops, reduced tillage, residue retention, cover crops, perennial crops, that kind of thing. Soil fertility requires manure plus synthetic fertilizers, compost, organic fertilizers. Those are all good practices, but manure by itself is not going to do it for us. So manure is a scarce resource. It's like that gold leaf. We can spread it thin, but it's not going to do what we need it to do. So back to this, is there a lot of manure for cropland or a little? Again, if we spread all the manure that we produce over all the cropland, it comes up to be about 0.8 tons per acre dry or 1.1 tons per acre wet at 33% moisture. So 1.1 ton of manure, you couldn't hardly see it if you spread that over. So it's really not very much. Again, manure is a valuable resource, but there's not enough of it to maintain levels of organic matter or nutrients. Here's the link for the blogs or the essays if you want to read them. Look at all the details and the calculations and my contact information. And I look forward to answering some of your questions.